So for this example, we want to find the exact value of sine inverse of root 3 over 2 and sine inverse of negative root 2 over 2. Now I'll say that with practice, you should be able to look at these and recognize that those are special and not rare values for the sine function, and be able to get where we're supposed to go pretty quickly. But we're going to take this step by step now because we're still learning. So for the first thing we want to talk about here is we want to understand that with these values, sine inverse of root 3 over 2 and sine inverse of negative root 2 over 2, we're essentially saying that we know something about a y-coordinate of a radius, where that y-coordinate is going to correspond to some angle theta. And then from here, for our second step, what we can do is take these inverses and throw the original onto the outside of them. Where, because we're doing this to one side, we've got to do it to the other. And this is also going to happen on that second one, but because I'm short on spacing, to save it till the end. Here, if we take sine of sine inverse, the defining property of an inverse is that when you compose it with what you started from, you kind of get nowhere. So we have that sine of theta, pulling that out, is just equal to root 3 over 2 in this case. Where in the second, if we apply the same sort of idea, we take sine on both sides, we will get that negative root 2 over 2 is equal to sine of theta, flipping over the equal sign so we have a little bit of clarity between the two cases. And then from this, we take our table of values here, and we're going to recognize that the value in particular that we're looking at in the first case, that root 3 over 2, only occurs once on our interval, only occurs once on the domain and range for which we are defining our function. And as a result, the value that we want for theta in that first case will end up being pi over 3. On the other hand, in that second case, we still only have one value where sine of theta is negative root 2 over 2. And that happens particularly at negative pi over 4. So for our second value, that's what we'll be working with. And next, we're going to see the same sort of thing, but in terms of cosine.